Good morning, sir.
Good morning, Yogita. So your work was checked, टिक किया है आपने ऑलमोस्ट. द ओनली थिंग इज कि जहाँ पर एच से सिखाया है ना वो सीबीएसई में एच लेकर के जहाँ पे इंटरवल ब्रेक हो रहे हैं ना वहाँ पर एच लेकर ही करना है. ठीक है ना.
हाँ सर.
भले ही स्कूल में आपको डायरेक्ट सिखाया हो तब भी, बिकॉज स्कूल में तो चेक नहीं होगा ना आपका. तो दिस टाइम बोर्ड से होगा. तो बोर्ड का जो पैटर्न है दैट शुड बी फॉलोड. ठीक है.
Yes, sir.
So we had completed till question number 24, 25, right? 24. Now we shall be doing today right from question number 26 onwards.
Sir.
ठीक है ना.
Yes, sir.
Exercise 5.1, question number 26.
Sir, I can't see the screen, sir.
Okay, just a minute. Now, is it visible now?
Yes, sir.
Exercise 5.1, question 26 is fx equals to k cos x upon pi minus 2x if x does not equal to pi by 2. And it is 3 if x equals to pi by 2. For example, in this question, if you don't take pi by 2 minus h or pi by 2 plus h, na, the answer will be wrong. How it is? Say, if you take x pi by 2 in place of x, the whole thing becomes 0. Is it? Cos pi by 2 is cos
Yes.
90 degree 0.
Yes, sir.
So whole thing will become 0.
0.
Getting it?
Yes, sir.
So you want to get the answer.
Yeah.
And this is 0 by 0 form, so you have to take cos pi by 2 minus h or cos pi by 2 plus h. So this is given that function is continuous and you need to find the value of k, right?
Yes,
So
sir.
LHL, for LHL we have limit h tends to 0 f pi by 2 minus h, right? So this will be limit h tends to 0 k cos pi by 2 minus h upon pi minus 2 pi by 2 minus h. So this will be k is constant, that should be taken outside. So limit h tends to 0. Cos pi by 2 minus h is sin h, and this is pi minus minus plus 2h. So got cancelled. So this is k by 2 limit h tends to 0 sin h upon h, and sin h upon h limit h tends to 0 is, the value is what?
1.
1. Yes. So this becomes k by 2 into 1, right?
Yes, sir.
And since function is
Continuous. Equal to.
continuous, and this value of function is for LHL as well as RHL. RHL is also k by 2.
2.
right? So LHL equals to RHL equals to F pi by 2. So this is k by 2 equals to 3. The value of function at pi by 2 is what? 3 given. So value
K.
of k will be 6. Answer. Check your answer from back side and confirm me.
Yes, sir. Yes, sir. K equal to 6.
Now we shall be doing question number 30.
Okay. Yes, sir.
From 26 to 30, all the questions are of the same type. So we'll be doing question number 30.
Mm.
Find the value of a and b such that the function defined by fx equals to 5 if x less than 2. 5 and it is ax plus b. It is ax plus b if 2 less than x less than 10. 21 if x greater than equal to 10. So we can see the value of function changes at two places, at
But 2
2
and 10.
x equals to 2 and at x equals to 10. So we shall check the continuity at however the function has been has it is given that function is continuous, right? So
Yes,
still
sir.
we shall take the continuity at x equals to 2 and at x equals to
10.
10. So LHL equals to equals to 5 and RHL is limit x tends to 2ax plus b. So that will be 2a plus b.
Yes, sir.
Since function is
Continue.
continuous at x equals to 2, therefore LHL equals to RHL equals to F2. So that is 2a plus b equals to 2a plus b equals to
5.
5. This is the first equation.
Yes, sir.
And second equation is from at x equals to 10. So limit x tends to 10 minus fx equals to. Here also I shall suggest you can take h means for LHL it is 10 minus h, for RHL it is 10 plus h. You can take it. There is nothing wrong in that.
Okay. So for every question, I'll take H only, sir. To stay
Yeah,
safe.
yeah, that would be better.
Okay.
So it comes to 10a plus b and limit x tends to 10 plus fx equals to it is given as 21.
Yes, sir.
So limit x tends to 10 plus 21 is 21. So LHL equals to RHL because function is continuous.
Continuous.
So it will be 10a plus b equals to 21. This is the second equation.
Yes, sir.
Okay. Now
So you
from
got
1
A
and
equal
2.
to 2, B equal to 1.
Yeah. From 1 and 2. 2a plus b equals to 5 and second one was 10a plus b equals to 21.
21.
10a plus b equals to 21. So subtracting these two equations, we have minus 8a equals to minus 16. So a equals to 2 and put the value of a in equation 1. So 2 into 2 plus b equals to 5. So b equals to 1. So value that answer that we got. Yeah, this is it. So answer we got a equals to 2, b equals b sorry a equals to 1. Is it? कितना था?
So A equal to 2, B equal to 1.
Yeah, a equals to 2, b equals to 1. So this will be the answer. Now from question 31 to 34, 33, this is of another type. So let's do question number 32. So in this type of question, what we do, since cos x is continuous, but we cannot say about mod of cos x. However, we know that absolute
Mod of
value
X.
function is always continuous.
Yes, sir.
Any absolute value function is continuous. So fx equals to is mod of x cos x. So what we do, we consider two functions. We consider gx equals to x and hx equals to cos x.
Yeah, okay.
And we know that these two functions are continuous. Absolute value function and cos x both are
Continue.
continuous function.
Yes, sir.
So we take h of gx equals to h of gx. This is called composite function, right?
Yes,
If we
sir.
combine two functions, this is called composite function. So h of gx is h of gx and h gx is what?
Cos X. Mod
So
X. H of mod X.
just a minute. Take g of hx because we have to take cos x into the mod. Na? So
Yes, sir.
take g of hx equals to g of hx. So g of hx is what?
Cos X.
Cos x, and gx is what? Mod of cos x. So
Yeah.
what we will do? It will be mod of cos x. Mod of cos x. That is what fx is. Since g and h both function both functions are continuous for all x, therefore the composite function function fx. Fx is what? H of g of
G of H.
hx. Yeah, g of hx is also continuous.
Yes, sir.
Now we can do in the same way we can do question number 30, 31 and 33. So we are doing question number 33 also. We have been given sine x fx equals to sine of mod x, right?
Yes, sir.
So let us consider gx equals to sine x and hx equals to mod of x. So let us take g of hx. G of hx. So this will be g of hx is what? Mod x,
Mod X.
right? And
Yes.
gx is sine x.
Yes,
So
sir.
in place of x, what we'll do? Sine mod x. So it becomes sine of mod x.
Sir,
Every
can you
time what?
explain again how it becomes sine mod X?
See what we do. If we take, suppose we take g2. So what do we do? We
Oh,
generally
sine.
suppose we,
Yes, sir.
yeah, we replace the variable every time.
Yes, sir.
If we take fh, what do we do? In place of x, we replace x by h.
Yes, sir.
So that's what we did over here.
Yes, sir.
We have replaced x by mod of x.
Yes, sir.
So we conclude we conclude that both g and h are continuous. Therefore, g of hx is also continuous. Continuous function. Got it?
Yes, sir.
Now taking question number 34. See, if 34 is coming for 2 marks,
Mm.
then you can just write both the absolute value function.
And they continue.
Yeah, mod of x is continuous and mod of x plus 1 is also continuous. So, suppose we have taken gx equals to mod of x and hx equals to mod of x plus 1. Then g minus h composite function is also continuous. If it is coming for more than three or more marks,
Mm.
5 marks, then you have to show all these things. So we are doing for long answer type, right?
Yes, sir.
And this question has been asked several times in the board.
Okay.
Fx fx equals to mod of x minus mod of x plus 1. So what we do, first of all, we define this. So we know that this is minus x if x less than 0, and it is x if x
Greater.
greater than or equal to 0. So for mod x plus 1, it is minus x plus what if x is less than minus 1, and x plus 1 if x is greater than equal to minus 1. Got it?
Yes, sir.
So now we shall combine, we shall define the combined function gx. Gx equals to mod of x minus mod of x plus 1. So what we do, first case is less than minus 1, x is less than minus 1. For less than minus 1, obviously this will be negative. First one is negative because for less than 0 it is negative. So for less than minus 1 is also negative.
Yes, sir.
So what we do,
Minus x minus.
so for less than x less than minus 1, we have minus x minus minus x plus 1.
Yes,
Is
sir.
it? So this got cancelled and this becomes 1.
Yes, sir.
And now it is for minus 1 less than equals to x less than 0. And the value of x is between minus 1 and 0. So
Yes.
for less than 0, it is minus x.
Mm.
But for less than 0, greater than minus 1, it is plus x plus 1. So this will be minus x plus 1, which becomes minus 2x minus 1. Is it?
Yes, sir. So, but this modulus too, sir.
Yeah, see, modulus of x is defined like this. I have already made you understand. X equals to minus x if x less than 0. What does it mean? If we take, suppose x equals to minus 2, then what will be the value of mod x?
2
Mod x will be minus x, and x is what?
minus.
Minus 2. So it has become 2.
Yes, sir.
The meaning is the same. The simple meaning is whatever comes out from the mod, it is positive.
Yes, sir.
But we define like that. Okay. So if we take less than minus 1, then it is minus of x plus 1. Minus x minus 1. You can check it. Suppose we are taking minus 2.
Mm.
So minus x of minus 1 minus 2. So minus 2 minus 1. The value is 2 minus 1, which is 1. Yeah,
Yes.
that is what we mean, how we define the absolute value function. And for x greater than equal to 0, so both the functions will be positive, right? So x minus 1 got cancelled. So this will be what? Equals to
Minus.
minus 1. Okay, so we have already defined functions through the interval. Now what we will do?
Check continuity with my and 0.
Yeah, yeah, we shall check the continuity at which points? Minus 1 and
0.
0. Yeah, we shall check the continuity of function, the continuity of the function. You need to do this question once again at home. Otherwise, you will not be able to do it in the exam. Okay? So you need to practice once again. We
Yes, sir.
shall check the continuity of the function at x equals to minus 1 and at x equals to 0. These 2 points are critical points where we can check the continuity of the function. So we have gx limit first at x equals to minus 1, limit x tends to minus 1 minus fx. You can do it directly because it is already very lengthy question.
Yes, sir.
So you can directly take x to minus 1 minus LHL. So limit x tends to minus 1 minus fx is what? Fx is 1.
1.
Is it?
Yes, sir.
Fx is 1. Yes, yes. Fx is 1. So answer is 1. Now for RHL, limit x tends to minus 1 plus fx equals to limit x tends to minus 1, and this is minus 2x minus 1. Is it?
Yes, sir.
So this becomes minus 2 minus 1 and minus 1. Again it is 2 minus 1 equals to
1.
1.
So it is continued.
So function is continuous at x equals to minus 1. Now at x equals to 0, limit x tends to 0 minus fx equals to limit x tends to 0. For less than 0, between minus 1 and 0, the value of function is minus 2x
Minus
minus 1. So this will become
minus 1.
minus 2, 0, minus 1 is minus 1. Limit x tends to 0 plus fx is limit x tends to 0 plus
Minus 1.
minus 1 is minus 1. So LHL equals to
Add
RHL equals to minus 1. Hence function
continued.
is continuous at x equals to 0. We conclude that,
There is no point of discontinuity.
yeah, we conclude that the function is continuous for all x belongs to R. Hence, there is no point of discontinuity. Points of discontinuity. So there are several questions in the exercises where it has been given that check the point of discontinuity. However, function is continuous throughout in its domain. So we shall say there is no point of discontinuity.
Yes, sir.
So this exercise has been completed. Now exercise we shall check the differentiability of the function. However, for differentiability only 2 questions are given, but at least one question we can discuss, right?
Hmm.
So Here it is differentiability of the function. Differentiability of a function. What is its definition? F dash x equals to limit x tends to c fx minus fc upon x minus c. This is the definition that is given in the NCERT book. However, in most of the reference books, you will find f dash x equals to, suppose in R.D. Sharma, you will find like LHD left hand
Derivative.
derivatives, left hand derivatives. Limit h tends to 0, f of x plus h minus f. Suppose we are checking at A or C, fc plus h minus fc upon minus h for LHD, and for RHD it is limit h tends to 0, f, it was c minus h, sorry, c minus h, fc plus h minus fc upon h. At x equals to c. C is any general point. If we are checking the continuity of differentiability of the function at x equals to c, then left hand derivative is fc minus h minus fc upon minus h, and RHD limit h tends to 0, fc plus h minus fc upon h. That is what LHD and RHD. So in exercise 5.2, there are two questions, question number 9 and 10. So we shall do one question number 9. And one more thing that is most important. Every differentiable function is continuous. Is continuous. So first of all, we shall check the continuity of the function. If the function is not continuous, then it can't be differentiable. Got it?
Yes, sir.
So doing exercise 5.2. And before that, we shall see the some derivatives of some standard functions. So derivatives of some standard functions. Suppose we have x to the power n का derivative, then it is n x to the power n minus 1. Okay?
Yes, sir.
Sin x का derivative is cos x. Cos x का derivative minus sin x, and derivative of tan x is sec square x. Derivative of sec x is sec x tan x. Derivative of cot x minus cosec square x. Derivative of cosec x is minus cosec x cot x. Derivative of log x is 1 upon x, and derivative of exponential function e to the power x is e to the power x itself, and derivative of a to the power x is a to the power x log a. Okay,
Yes, sir.
so derivative of 1 upon x is what? Minus 1 upon x square. 1 upon x square का derivative is minus 2 upon x cube, and so on, right? And root x का derivative is 1 upon 2 root x. Why I am especially, these all can be done with this rule, this first one. But why I am writing, because we shall be frequently using this
Okay, sir.
without doing an x and minus 1, right?
Yes, sir.
And derivative of sine inverse x is 1 upon root over 1 minus x square. And this is also derivative of cos inverse x is minus root 1 minus x square. So we can say cos inverse derivative of sine inverse x is root over the derivative of cos inverse x is derivative of minus of derivative of sine inverse x. And tan inverse x, derivative of tan inverse x is 1 upon 1 plus x square.
Yes, sir.
And apart from that, there are two special rules that are called product rule, that is u dash v plus v dash u. This is called product rule. And u by v dash
So,
is,
what is U and V, sir?
two functions are there. If two functions are in the product, suppose we have x cos x. X is one function, algebraic function, and cos x is another function, trigonometric function. If the product of two functions are there, then we use this product rule.
Okay, sir.
If it is in quotient form, then we use v of u dash minus u of v dash upon v square. This is called quotient rule. This is called quotient rule. Okay, and there is chain rule. While doing the derivatives, we have to follow chain rule. What does it say? If there is function under the given function, then we shall continue the means derivative, finding the derivative till we get the one. So we shall understand chain rule while doing the sums. So exercise 5.2. Suppose exercise 5 point. Suppose exercise 5.2. Suppose we have been given question number 2. y equals to cos of sin x. So differentiating with respect to x. So derivative of y with respect to x dy by dx.
Hmm.
So we will take minus sine of sin x, right? But since we have taken sin x in place of x, so we have to multiply the derivative of sin x as well. Let us do elaborate it so that you can easily understand. I just elaborate it. So first what we have to do, we have to find dy dx of d of derivative of cos of sin x,
Sin x.
right? So first what we will do, we will write derivative of cos, that is minus sine, right?
Hmm.
And minus sine of sin x into derivative of sin x. It is called chain rule.
Okay, sir.
If any function is coming under another function,
Hmm.
then we will find the derivative till we get the 1. So derivative of, so this become minus sin x, and derivative of cos sin x is cos x, and derivative of x is what? 1.
1.
Derivative of x is 1. So we find the derivative till we get 1. So final answer is dy by dx equals to minus cos x into sine of sin x. This will be the answer.
So derivative of a constant is 0, sir.
Yeah, derivative of a constant is 0. So question number 7. Y equals to 2 root cot of x square. So dy by dx differentiating with respect to x. 2 d by dx root of cot x square. So 2 times derivative of root x is what? 1 upon
2 root x.
2 root x. So in place of x we have cot
Cot
x square.
square.
So what we will do? We
Difference.
will,
Cot.
yeah, minus cosec x square, and again in place of x we have x square. So this will be
2.
multiplied by 2x. So this is minus 2x cosec x square upon root over cot x square.
4x. No, sir.
How it is?
Oh, no, no, sir. Can 2 got cancelled. Yes, sir.
So it is minus 2x and upon sine x square, and this is root cos x square into root sine x square. So this can be cancelled out by root sine x square. Is it?
Yes, sir.
So minus 2x upon root over sin x square into cos x square. Again simplifying. However, you can leave there only, but answers in NCRT
Mm.
is in simplified form. Okay, so minus 2x, and what we do, we multiply by 2 over here, sin x square, cos x square, and hence we have to divide, multiply root 2, hence we have to multiply in numerator also. So this is minus 2 root 2 x upon root sine 2x square. How it is? Sin x into cos x is sine 2x. So basically we have used the identity of trigonometric identity over here.
Mm.
Check your answer from back side.
Minus 2 root 2.
Is it?
Yes, sir. No, so they've given sin x square into
Mhm.
sin 2x square, the denominator.
Denominator sine x square into,
Root over sin 2x square
yes, that is there, root over sine 2x square
into sin x square.
into sine x square. Why it is sine x square? Let me check it. No, no. This will be the correct answer. Previously, it was the same answer in the NCRT. And now it has been changed to right root over. That could be the printing error. Root sine 2x square will be there only. Okay. However, we can leave the answer here also, right? But we should simplify as we can.
Mm.
Try to write the answers in simplified form as per the NCR. Now we will be doing question number 9. 9, 10, both the functions are for differentiability, and in both the questions we have to show that the function is not differentiable. So it is injustice. Only two questions are there, and both are of the same type
Mm.
to prove not differentiable.
So we can use continuity if it's not continuous then.
Yes, if it is not continuous. Question number 10.
Mm.
Greatest integer function is never continuous.
Mm.
So we should not check the differentiability of the function. So we
So
will be doing question number 9 here. So in question number 9, we have prove that the function fx equals to x minus 1 fx equals to mod of x minus 1. We know that mod of x minus 1 is a continuous function for all real x. Hence, we check the differentiability differentiability of the function. Got it?
yes,
If
sir.
the function is not continuous, then we shall not check the differentiability of the function,
Mm.
because every differentiable function should be,
Continuous.
yes. If it is not continuous, then it cannot be differentiable. So we shall not check the differentiability of the function. So LHT put x equals to, where we have to check at x equals to 1. At x equals to 1. Put x equals to 1 minus h. So limit h tends to 0, f1 minus h minus f1 upon minus h. So this is limit h tends to 0. Function is 1 minus h minus 1 minus 1 minus 1 upon minus h. Got it?
Yes, sir. So then minus h by you get minus 1.
Yeah. So this is limit h tends to 0, h upon minus h upon minus h. So this is minus 1. RSD. Put x equals to 1 plus h as x tends to 1, h tends to 0. So limit h tends to 0, f1 plus h equals to limit h tends to 0, 1 plus h minus 1 minus 1 minus 1 upon h. So this is limit h tends to 0, h upon h, which is 1. So we see that
LHD not equal to R.
not equal to RSD. Therefore, function cannot be
Differentiable.
differentiable. Therefore, function is not differentiable at x equals to 1. Therefore, function is not differentiable at x equals to 1. Okay,
Yes, sir.
so there are many more things to do. We shall end up today here itself, and you will be doing differentiability because from here 5.34, 5.3 it will take only 2 minutes, 3 minutes, because we do not have to do much in 5.3. Okay,
Yes, sir.
no, sorry, 5.3 we have to do question number 9 to 15. These are the important questions, and these are on the rule as on the basis of the rule of inverse trigonometric function. And here comes the property of implicit function. There are two types of function, explicit and
Implicit.
implicit function. Implicit functions are those functions where both at least two variables comes together. Right? Here we can see x, y, both are coming together and we cannot separate them easily.
Hmm.
Then this is called implicit function. An explicit function is that where y and y a dependent variable is separated with the separated from the dependent variable x.
Hmm.
Means y is written in the form of x. Y can be written as the form of x.
Hmm.
As the terms of, rather than we should say as terms of x. So we shall be doing 5.3 onwards. 5.3, 5.4, 5.5. These three exercise will be completed by tomorrow. So if you complete till 5.2 and submit it, I have checked your work and submitted. You must have got the mail ID. You must have got mail regarding the same. However, I have not submitted over there by checking with the red pen. However, there is option for the same as well. But what happens that is for that we have to give permission to the third party app, that is Doc Sign app. That's why I didn't. I just wrote the comment over there.
Okay.
How is your mom and dad?
They're good, sir.
Okay. So, and how is the study in other subjects going on?
Okay, sir.
So you have science stream, na?
Yes, sir.